Okay, we'll get back to section 3.2 here. I was going to show you one more example of where you're completing the square. And so let's go ahead and do that now. We got, what if we want to solve the equation, which is given by 2m squared plus 10m minus 3 equals 0. And we're going to complete the square. Okay, so again, the first thing is we need a 1 in front of m squared. So I'm going to divide both sides by 2. I got m squared plus 5m minus 3 halves equals 0, and I'm supposed to add 3 halves to both sides. Okay, so again, those two things are just the setup for completing the square. I haven't done any completing the square yet. I'm all set up to do that now. So I need to take half of the number in front of m squared, and I add that new number to both sides. So half of 5 would be 5 halves. Squared is 25 fourths. So I'm going to have to add 25 fourths to both sides. Okay, and I've done that. So on the left side, it's always going to factor, and also the factors are going to be the same. Okay, so I'm going to factor m squared plus 5m plus 25 fourths. And that's going to factor as m plus 5 halves times m plus 5 halves. Again, it's always going to be the number that you're squaring in the previous line. To get the 25 fourths, I had to square 5 halves. So it's like I don't even have to think of it, right? On the right, I've got to get my common denominator, which would be 4. So 3 over 2, that's the same as 6 over 4. So I got 6 over 4 plus 25 over 4, that'd be 31 over 4. And now take the square root of both sides. So m plus 5 halves would be equal to plus or minus the square root of 31 over 4. The square root of 4 is 2, right? So then if I subtract 5 halves from both sides, m would be negative 5 halves plus or minus the square root of 31 halves. And if I get a single fraction out of that, m is equal to negative 5 plus or minus root 31 all over 2. Okay? Now we didn't try it, but this guy is not going to factor nicely, right? Because these nasty numbers here, these are the two factors. Okay, and these are not numbers that I would guess, if I were trying to factor this. So the way that we did the problem is actually the best way to do the problem. Okay? Now, there's 4 methods for solving a quadratic. Okay, we've looked at factoring, using the square root property, completing the square, and then there's also the quadratic formula. Here's what the quadratic formula is all about. It says the solutions to a quadratic equation, ax squared plus bx plus c equals 0, a is not 0, are given by the formula x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Memorize that. That formula is going to come up so often, it's just worth knowing. Okay? You're going to see that formula a lot. So, let's try an example. What if I want to use the quadratic formula to solve this guy? 2x squared minus 3x minus 5 equals 0. Well, a is 2, b is negative 3, and c is negative 5. And so I'm just going to plug in those numbers into this formula here. So x would be the opposite of b, that's 3, plus or minus the square root of b squared negative 3 squared is 9, minus 4 times a is 2, times c is negative 5. And this is all over 2a. 2 times 2, that'd be 4 in the denominator. Okay. And so then from that, we have 3 plus or minus the square root of 9 minus a negative, means I'm adding something to 9. It'd be 9 plus 40 is 49, right? And the square root of 49, that's 7. And then 2 times 2, that's 4, not 2. So I'm looking at 3 plus or minus 7 over 4. Well, 3 plus 7 is 10. 10 over 4 reduces to 5 halves. And 3 minus 7 is negative 4. Negative 4 over 4 is negative 1. Okay, so those would be the two answers there. You always have two answers whenever you solve a quadratic. That will always happen, so keep that in mind. Now, let me ask you, so we use the quadratic formula for this problem. Would I maybe try to factor this, or would factoring be the way to go? Yeah, factoring is going to be the way to go. So this equation will factor nicely. So the factors of 2 are 2 and 1, so it'll be 2x and x. The factors of 5 are 1 and 5, so we have 5 and a 1. That's a negative 5 also. So I know that the signs have to alternate, plus minus or minus plus. And it looks like it's going to go minus plus. So if I FOIL this back, I should get this line right here. 2x times x is 2x squared. 2x minus 5x is negative 3x in the middle. That was good. And then negative 5 times 1 is negative 5 at the end. That's good. Okay, so then 2x minus 5 equals 0. That means that x is 5 halves. X plus 1 equals 0 means that x is negative 1. All right, so this guy factored to begin with. Now, we didn't use the factoring method. We used the quadratic formula. Okay, but in order, here's how I want you to think of solving a quadratic equation. If I give you any quadratic equation, and I don't tell you what method to use, okay, and some of these problems, like, they're going to tell you what method to use, and some of them they're not going to say anything, okay? So if you're not told, then the order that you want to try things are factoring, okay, and I would just, give it a couple of seconds to see if the equation factors. If it doesn't factor, or if you can't see the factors, then plan B, your next best option, is going to be to use the quadratic formula. Okay? This completing the square stuff, we tend not to use that, and I'll mention why after we look at some more examples. Okay? We tend not to use this just because one little slip up and there goes the whole problem, and the completing the square method is kind of tedious and it's kind of weird here, So again, think factoring first, and then if it does not factor, then the next thing is you're going to use the quadratic formula. Okay. Here is another example. So how about what if we wanted to solve the equation, which is given by 2x squared plus 1 equals negative 4x? Solve for x. Okay. A would be 2. B would be 4, not negative 4. So I want to make sure that before I identify A, B, and C, I have to make sure that I'm in the form ax squared plus bx plus c equals 0. I'm not in that form. So I need to get everything onto the left there. I'm going to have 2x squared plus 4x plus 1 equals 0. So A would be 2, B is 4, and C is 1. Which means that x is the opposite of b. The opposite of 4 is negative 4. Plus or minus the square root of b squared. 4 squared is 16. Minus 4 times a is 2, times c is 1. And this is all over 2a. 2 times 2, that'd be 4 in the denominator. So now all my information has been plugged into the quadratic formula, and it's just a matter of simplifying things as far as I can go there. So how about if I take 16 minus 8, that's 8. And root 8 breaks down as 2 root 2. So I'm looking at negative 4 plus or minus 2 root 2 all over 4. I can take that a step further. If I factor a 2 out from these two terms and then cancel it with part of the 4, I'll be able to simplify this. Okay, and like anything else that I do in math, simplify things as far as possible. So if we factor 2 out, 2 times negative 2 is negative 4. 2 times root 2 is 2 root 2. Okay, and 2 over 4, that's 1/2. So I get negative 2 plus or minus root 2 all over 2. That would be as simplified as I can get it. Okay, now I sometimes see this, where a student will cancel the 2 and the negative 2. You can't do that. Or they'll cancel the 4 and the negative 4. You can't do that. Okay, because you're adding and subtracting a number up top. Now, it'd be different if I'm multiplying, then I could cancel. Okay, but this would be as simplified as I can get it. I cannot simplify things any further than what I have here. Okay, so don't cancel the 2 with the negative 2. You'll be led to a wrong answer if you do that. Okay, now would I try to factor this? 2x squared plus 4x plus 1? No, because these nasty numbers here are the factors, and these are not natural numbers that I would guess, if I'm trying to factor. So actually, the way that we did the problem is the best way to do the problem. Okay? Let's try another one. So in this example, we want to find the x-intercepts for the function h of t equals negative 4t squared plus 6t minus 1. So the x-intercepts are found by letting y be 0. Y and h of t are the same thing. So I need to let h of t be 0 and then solve. If I multiply both sides of the equation by negative 1, the reason I did that is because usually, if I need to use the quadratic formula, which I will here, we kind of prefer to have a positive a value. I didn't need to do that. Like, I could have used the quadratic formula in this form, but usually a is we like that to be a positive number. So I got 4t squared minus 6t plus 1 equals 0. That's not going to factor nicely no matter what I try for the factors. So let's use the quadratic formula there to get t. T is equal to the opposite of b, that's 6, plus or minus the square root of b squared negative 6 squared is 36, minus 4 times a is 4, times c is 1, and this is all over 2a. 2 times 4 would be 8 in the denominator. Okay, so then from that, we have underneath the square root sign, 36 minus 16 is 20. Okay, so I'm looking at 6 plus or minus root 20 over 8. Root 20 is going to break down as 2 root 5. Okay, so this here would simplify. Okay, so if I factor out a 2 from these two terms, let's see, 2 times 3 is 6. 2 times root 5 is 2 root 5. And so I factored out a 2. I'm going to cancel that with part of the 8 that I see in the denominator. 2 over 8 is 1/4. So my answer would be 3 plus or minus root 5 all over 4. Those would be the two numbers. You always have two solutions whenever you solve a quadratic equation. That will always happen. Keep that in mind also. Okay? And, like, if I did try to factor this, I wouldn't be getting very far because these numbers here would be part of the factors. Okay, and these are not numbers that I would think of, with factoring. All right, so again, in order, if I have any quadratic equation, the first thing I think of is factoring. And just give it a couple of seconds. If you can't see the factors, then the next thing that you want to think of is to use the quadratic formula. Unless you're in a situation where you can use the square root property. So like, with these examples, like I'm all set up to take the square root of both sides. And so why don't we, use the square root property there, okay? The square root property is kind of its own thing though. And then as a last resort, there's the completing the square method, okay? We prefer not to use the completing the square method. Now, why is that? Well, let me ask you this. So here's the quadratic formula, right? X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Where did that come from? Like somebody had to think of that, right? So where did that formula come from? It didn't come out of nowhere. Well, what somebody has done for us is they've actually gone through the completing the square method with this general form. So they have an equation, ax squared plus bx plus c equals 0, and they complete the square on that. So they get a 1 in front of x squared, and then they bring the constant over to the other side. They take half of the number in front of x squared, and they add that to both sides, right? And they keep doing that, and they led to this formula. So this formula is the simplified version of completing the square. Okay, so that's why I said that if you have any quadratic equation, we prefer not to complete the square because somebody has already done that for us. So why go through the procedure of completing the square when somebody's already done that for us? We just use the formula. All right. So the quadratic formula comes directly from completing the square. Okay. All right, we'll go ahead and stop the video right there. And now, also in this, so I've got a worksheet here, which we'll do in the next video. But I got it says quadratic equations and applications. So we'll I've got some equations here. You're going to use the square property. Here's some where you're completing the square. Here's some where you're using the quadratic formula. Okay, and then starting with problem 13 is some story problems related to a quadratic equation. Okay, these are all related to a quadratic. So we'll do some of these in the next video there, and we'll go ahead and stop the video right here.